Okay, so now for the multiple choice. For this part, we're going to use the interval negative pi to pi. On what intervals is f decreasing? Means where f prime is less than 0. Now, since f of x is an integral, we kind of need to rewrite this because the derivative is going to cancel the integral, but we need the x to be on top, the constant on bottom. Then we have t, sine of 2t, dt. So now f prime of x, derivative cancels the integral. We're still going to substitute in. So we have x substituted in for t. And then the derivative of x, which is 1, gets substituted in for dt. Now I don't have to do the bottom part because the derivative would be 0. Okay, now, in order to figure out the critical numbers, I'm going to set the derivative equal to 0. Oops, one thing I did forget, the minus sign in the front. When I flip the integral over, I do have to have a minus sign in the front here for the flip. So there should be a minus there. So now, either negative x equals 0, so x equals 0, or sine of 2x equals 0, which means 2x would have to be on that interval. Since it is a 2x, I go twice around. So negative 2 pi, negative pi, 0, pi, and 2 pi are the values that would make sine 0. If I divide everything by 2 now, I get x equals negative pi over 2, 0, pi over 2, and pi. Okay, so now if I do a number line for f prime between negative pi over 2, 0, pi over 2, and pi, let's test values into the derivative. So if I substitute in negative 3 pi over 4, I get negative times negative is positive for the negative x, and then sine of 3 pi over 2, negative 3 pi over 2 is actually positive pi over 2. That's also positive. I use negative pi over 4. Negative times negative makes positive. And sine of negative pi over 2 is actually in the position of 3 pi over 2 is negative, so I have negative overall. If I use pi over 4, I get negative x, so that's negative, times positive is also negative. And then the next part, I would get 3 pi over 4, so negative 3 pi over 4 makes negative. Sine of 3 pi over 2 would be negative, so we get positive. Okay, so now we need to consider where the f is decreasing. So the answer choices for this year's exam were a little bit messed up because the answer would technically be negative pi over 2 to 0 with a pause, and then from 0 to pi over 2. But they only gave us negative pi over 2 to pi over 2. So it's a little bit off, but that happens. Okay, the next question says, for approximately what percentage of the values of x is f of x increasing? So f of x is increasing when f prime of x is greater than 0. We are not going to do this by hand other than f prime of x cancels the antiderivative, substitute in x for t, which means dx goes in for dt as 1, and then the 0 on bottom is unnecessary. Now, the percentage of values of x. If we're going from negative 2 to 2, then the total width of that window is 4 units. We're asking how many units would f prime, which is cosine x squared plus x, be positive. So we're going to use our calculator. And we're going to put this f prime into our y1, we're going to make sure our window is only from -2 to 2. And then we're going to zoom 0. Okay, so for my calculator, I'm going to clear, and I'm going to type in cosine x squared plus x, window, -2 to 2, and zoom 0. Okay, so noticing on the situation what I have here, or what I could drag over from my calculator, on that window, I have positive values here and here. So what I need to know is the total width of this part and the width of this part to figure out how much out of the 4 units are positive. So I have y equals 0 in my y2 so that I can intersect. So enter, enter. And I want to find first the value over here at about negative, let's say 1.7, because we know that -2 is the left side. So it'll find that value. So negative 1.849. I'm going to find the next intersection. And it appears to be close to 1, so I'll type 1. And 0.849. So the total width of that particular piece is negative 1.849, or rather, sorry, 0.849 minus the negative 1.849. Or we could add the two absolute values together, 2.698. So I have 2.698 plus, we need the width of this section. So if we find that intersection, and this appears to be closer to 1.7, 1.728, then that distance is how far from 1.728 to 2. So since that x was the one that I was just on, still in there, I can do 2 minus the previous x value and get 0.272. So the width that's positive altogether is the 0.272 and the 2.698. So 2.97. So it's 2.97 out of a total width of 4. Or 0.7425. So approximately 74%. Okay, the next part, again, is doing the fundamental theorem of calculus, where the derivative cancels the antiderivative. But this time, I'm going to substitute in t. It's going to get replaced by x cubed, which means dt has to get replaced by the derivative of t, which is 3x squared. So that makes this tangent of x cubed to the 4th minus 1 times the derivative of t. So that's going to be 3x squared tangent x 12 minus 1, or d. Okay, the next question, the cheesesteak factory at the stadium has 25 cheesesteaks ready to sell when it opens. So the initial value is 25. We have a window from 0 to 20. It cooks cheesesteaks at a rate of 4 steaks per minute and sells cheesesteaks at a rate of 1 plus 6 sine 2 pi t over 41 steaks per minute. So the rate in that we're adding cheesesteaks is 4, but then people are eating them at the rate out. Okay. At what time is the number of cheesesteaks ready to sell at a minimum? Okay, so to do this, we have to figure out always max and min for rate in, rate out questions are when the rate in equals the rate out. So I'm going to get that on my calculator first. And then remember, I have to check the endpoints. So I'm going to put in 1 plus 6 sine of the fraction. Actually, I'll do my rate in first. My rate in is actually 4. And then I'll do my rate out as the next one as 1 plus 6 sine fraction 2 pi x over 41. Oops. There's my, okay, so that's the rate out. So rate in and rate out in that order. I'm going to do my window, 0 to 20, and zoom 0. So I'm looking for where the rate in equals the rate out. So there's the rate in, 4, the rate out that we're selling. That's the darker line you see now. So there are 2 times we have critical numbers. So I'm going to intersect. And I'm going to choose the 1 since we're going from 0 to 20. Maybe this is at 5-ish. So I'll guess 5. And so 3.41667. So I'm going to do my table. Time and the number of cheesesteaks. Times 0, I have 25 cheesesteaks. And my critical number, 3.41667. Going to get some cheesesteaks. The next critical number, closer maybe to 15, 17.0833. I need to know how many cheesesteaks there are. And at time 20, I need to know how many cheesesteaks there are. Now the number of cheesesteaks is equal to the initial number plus the change. Was the integral from 0 to k of the rate n minus the rate out. So since this is not a free response question, it doesn't matter the work. So my rate in was y1, rate out, that's fine. You could never write that on a free response, no calculator notation. Okay, so now that means that I have 25 plus the integral from 0 to time 3.41667. The rate n, y1, minus the rate out, y2, dx. So 30.0046. I can then change that integral by going up and highlighting and then set enter. Go back to the beginning. Just to change, I still want the 25 and I still want to start at time 0. I'm going to clear this part and type in 17.0833. So 3.191. And then at time 20, I'm going to clear just that part and go from 0 to 20. Still the initial value plus the change, so 6.81 total. So at what time is the number of cheesecakes a minimum? So that's going to be at time 17.08, so 17.1. The maximum will be at time 3.4. Okay. The number 5 is actually one of the harder problems for people to get because they're showing you the graph of f prime. And f prime are the y values of this graph. And so which of these could be f? So what I like to think about on here is that f prime is positive, because of the y values. And then at 0, f prime is 0, because that's the value for f prime. F prime is not undefined there. It actually has a value. And then to the right-hand side, f prime y values are also positive. So if I'm looking at these graphs, I need a graph that has a positive slope, a 0 slope, and then a positive slope. That only happens at 1. For the derivative to exist, we can't have function 3 because there's no derivative at a jump. Okay, this next one's also a calculator questions. So this time it says how many points of inflection does the graph have? So points of inflection means that f double prime changes signs, or f double prime would be the slope of f prime has to change signs. So since we have f prime, I'm going to put that into my calculator. I'm going to clear out the former stuff that I had. Okay, so I have parentheses x minus 1, close parentheses, e to the sine of 2x, close the sign, come back down, on the interval 0 to 2 pi. So I have to set my window, 0, 2 pi, zoom 0. So as long as you can tell from your graph how many times f prime changes a slope, changes signs, you're fine. Or what you can do is turn off f prime, turn on the derivative of y1, which is technically f double prime, and we could graph that. So for this one, we have f prime are the y values. So f double prime would be the slope. But we could also graph the derivative, f double prime, to see the f double prime graph. It's a little slower though. To see how many times f double prime. So here, f double prime are the y values, to see where f double prime changes signs. So we have negative, positive, negative, positive, negative, positive. So it would change 1, 2, 3, 4, 5 times. Or here we have a negative slope, positive slope, negative slope, positive slope, negative slope, positive slope. So 1, 2, 3, 4, 5. So either way, you're going to get that f double prime changes signs 5 times. Okay, so the graph of f double prime is given. So the graph of f double prime, those are the y values. So the area would actually give me f prime. It says on which of these is f prime decreasing? Well, f prime is decreasing when the slope of f prime, f double prime, is less than 0. So what we really want then is to look at f double prime, which are the y values. And the y values are positive, positive, negative, positive. So the y value, f double prime is negative between 4 and 6. If f double prime is negative, then f prime is decreasing. Okay, the next question says the graph of f prime, the derivative of f is given. So f prime is the y values. F double prime is then going to be the slope. And f would be the area. So f is increasing on 2 to 3, means that f prime is greater than 0 between 2 and 3. Well, f prime are the y values. The y values are positive between 2 and 3, so yes. F has a local minimum at x equals 1, means that f prime has to be minimum, take that back. F prime has to be negative to positive at 1. So f prime are the y values, and the y values are not changing at 1. So that's no. So that's going to be the one that's not true. If we look at these others, a local max at 0 means f prime is positive in the negative, which is true. The y values are f prime, and the y values are positive in the negative at 0. F is differentiable at 3, means f prime of 3 exists. F prime of 3 does exist. There is a value for 3 on this graph. F is concave down, would mean that f double prime is less than 0. So f double prime is the slope, and between negative 2 and 1, the slope, which is f double prime, is negative, so that's true. So there's only one answer where the statement is not true. Okay, so this next one is giving us the derivative function. It says C represents the largest value of x on the interval 0 to 2, where there is a relative extrema, and D represents the smallest value of x on the interval where there is a relative extrema. So what we're saying then is when we're looking at the x-axis, C is the largest value and D is a smaller value. Means they occur in that order. So relative extrema occur whenever, so they're not saying max or min specifically. So when f prime changes sign, then we either have a max or a min, depending upon which order, but we don't even care which order. So we're just going to look f prime x minus 1 quantity squared times the cosine of x squared plus 1 on the window 0 to 2, zoom 0. We did not do a very good job of zooming 0. Give me 1 second. Change that. Oh, I left my derivative turned on. Gotta turn that off. It's not going to work. Try again. So now we're going to try zoom 0 again. I said, that is a horrible graph. Okay. So double check our window. 0 to 2. And zoom 0 again. Okay. So on here, I like to intersect with 0, so I'm going to put 0 back in. So we change from positive to negative, right here in the center, at x equals 1. And we change again, further over toward 2, so I'm going to type in like 1.9. So here. So we change from negative to positive and have a minimum when f prime changes from negative to positive. Okay, and now here, I'm not sure what's going on in this part, but it says the smallest and the largest. So we did have a value of 0 at 1, but we really didn't have a sign change there. So if we want to see that, we can zoom in a little bit or zoom box, either one, but we zoom in a little. We can see that we have a sign change. To our window from, say, 0.5 to 1.5. And zoom 0, we can see better what's happening in this section. So we do change sign at the 0.7. We don't actually change signs at the 1. Okay. So the smallest value for x is the 0.75. The largest is the 1.9. So the difference between those two things is 1.926, 7 minus 0.7555, 1.1712. The next one says to let g be strictly decreasing such that g of x is less than 0. So we have two pieces of information there. G is strictly decreasing, means g prime is always negative, and we're also told that g is always negative. Which of the following is true? So if we do the derivative, we get the derivative of the first, keep the second, plus the first times the derivative of the second. Okay. So now at x equals 1, we know the first derivative is 0. So we know f prime of 1 is 0, because the first term plus the second term would be 0 because of these two factors. So f is not strictly decreasing or increasing. Now, if we do the second derivative of f, we get the derivative of the first, which is 2. We can hold. And the derivative of x minus 1 is 1. And then keep the second, plus the first, times the derivative of the second, plus the second product is the derivative of the first, keep the second, plus the first, times the derivative of the second. So the second derivative at 1 is 2 times g of 1. And all of the other terms have x minus 1 in them. So if I substitute 1 into here or here or here, these pieces actually cancel out to 0. So the second derivative is 2g of 1. And since g is always less than 0, the second derivative of f is less than 0. So what we have is f prime of 1 is 0. And f double prime of 1 is less than 0. So we have a concave down function with a 0 slope. So that means we have a relative maximum. Okay, last two questions. The function g is defined as x squared minus f of x. Okay, so
I'm sorry.
this stuff. So g of x is x squared minus f of x, where the graph of f prime is shown. Finding class all points for the relative extrema of g. So we need to do relative extrema for g, so we do g prime, which is 2x minus f prime of x. So if we want this to equal 0, it means we have 2x minus f prime of x has to equal 0. Which really means that f prime of x has to equal 2x. Graphically, that means that f prime of x graph has to equal the y equals 2x graph. So that happens at x equals 0 and at x equals 2. Now, if we go back to consider the g prime graph, it's the blue line minus the curve. So if we're looking at that here, the blue line minus the curve for this part, blue line minus curve is positive. And then x equals 0, they intersect. Now, blue line 2x minus curve, blue line minus curve here is actually going to be negative because the blue line is below the curve. So blue line minus curve would be negative, then x equals 2. And then blue line minus curve after that, blue line is bigger, so positive. So that means we have a relative max at x equals 0 and a min at x equals 2. So the graph of the piecewise linear function f is shown. This is f. Which of the following is greatest? So now g is defined as the area. So if we're talking about g of negative 4, g of negative 4 is from 1 to negative 4, the area of f, which is negative of negative 4 to 1, which is the correct order, which is negative. And from negative 4 to 1, I'm going to figure out these areas. And so I have 1.5, 6, 3, and 1. So the negative 4 to 1, I'm going to keep the negative factored out. From negative 4 to 1 is 1.5 minus 6. So it's negative 4.5. So positive 4.5. Okay, g of negative 3 is from 1 to negative 3 f of t dt, which is negative of negative 3 to 1 f of t dt, which is negative of negative 6 for 6. G of 1 is the integral from 1 to 1. Doesn't even matter because that is always 0. Okay, and the integral, so G of 4 is the integral from 1 to 4 f of t dt, which is in the correct order, so just the 3. And G of 5 is the integral from 1 to 5 f of t dt, which is already in the correct order, so we don't have to flip it. So we have from 1 to 5. From 1 to 5 is 3 minus 1. So the maximum value occurred at 6 here. So it was G negative 3.